All right, let's go. So now we are going to look at a couple examples where we have different bases. All right, different bases. So this first example, we got 16 and 4, and I think it's the easiest transition is if you can just change one, just change one. So let's write 16 as a number with base 4 because we can do that. Now I could write them both as numbers with base 2, but if I don't have to, then why? Why do it? So we're going to write this as 4 to the second power is greater than or equal to 4 to the x plus 5 power. And because my bases are the same, that means I can just go ahead, drop them, and then rewrite this without the bases present. So the way I would solve this, I have 2 is greater than or equal to x plus 5. So let's subtract 5 from both sides. You get -3. So no sign flip involved in this because adding and subtracting, it doesn't apply, right? It's just multiplying and dividing by negative numbers. So that cancels out. You get x is less than or equal to -3. I'm going to write this the other way because that to me makes the most sense. X is less than or equal to -3. And so now for my check step, let's grab a value that is less than or equal to -3 and put it in. I think it's a little counterproductive to actually use -3 because that's sort of what we solve for right now. So let's use -4. So we're going to use -4. So let's put that in. So we have 16 is greater than or equal to 4 to the -4 plus 5 power. Let's make that -4 actually look like a -4. So you get 16 is greater than or equal to -4 plus 5 is 1, right? 5 minus 4 is 1. So you have 4 to the 1 power, which is the same thing as saying 16 is greater than or equal to 4, which is absolutely true, right? So it checks out. It's good. We like that. And yeah, we feel successful. So again, just get your bases the same, and then you can go ahead and do what you want to do. All right, now we've got some sort of skullduggery going on here, some sorcery. So here's what I know. All right, I know that we need to know our powers of things, right? And so I'm going to hope that I can write 243, and I'll deal with it being the bottom of the fraction in a second. But I'm hoping I can write that as base 3. So let's go down our 3's, right? So we know that 3 to the 1 is obviously 3. We know that 3 squared is 9. Then you multiply by another 3 to get 27. Do it again, and you're at 81. And then one more time, all right, times 3 is going to give you 4, and then 2, or no, carry nothing, and you get 243. Sorry, not 4. 3 times 1 is 3, not 4. So you get 243. So that is 3 to the 5th is equal to 243. So we are going to rewrite this, okay, as a number with base 3. Now, the problem we have here is that I still can't just drop stuff because this is actually, this is more like 1/3 than it is 3, right? But here's what I can do is I can use a negative exponent and then move this thing into the other position, right? Move this thing up, and then it will work. And so I'm going to say 3 to the 2x minus 3 is greater than or equal to, so I'm going to take this whole thing, I'm going to move it up top, and when I do that, I just basically change that to negative. So it's greater than or equal to 3 to the -5th power, right? So we're going backwards. We're not used to that. We're used to going, the other way, right? And so now my bases are the same. So you can say 2 to the x minus 3 has to be greater than or equal to -5. So we're going to add 3 to both sides, and you get greater than or equal to -2, and then you get 2x over here. Divide by 2, and you get x is greater than or equal to -1. All right, so now for my check step, I can actually use my favorite numbers, and we are going to use 0, all right, and put that in this equation, and because 0 is greater than or equal to -1, right, it fits. So go 3 to the 2 times 0 minus 1 is greater than or equal to 1 243rd. Well, this is 2 times 0 is 0, right? And then 0 minus 1 is -1. So they're saying 3 to the -1 power is greater than or equal to 1 over 243. That's another way of saying 1/3, right? Because this would, you take this, put it over 1, and then flip it, right? So 1/3 to the 1 power is 1/3 is greater than or equal to 243rd. And 1/3 is bigger than 1 243rd. Remember, fractions are the opposite as integers, right? So yes, this works out, and that answer is absolutely 100% legit, and we like it. So I hope this video has been helpful to you. I'm going to stop the video here, and then we will pick up with one last example before we get into the next video after that, which is the practice problems. All right, so thanks for watching.